Streaming. And we are live. All right, welcome to Data Science Club number 5. Today we're going to be talking about using XGBoost, which stands for Extreme Gradient Boosting, which sounds a little bit like a monster truck rally, but there you have it. It is a machine learning model that's really good at modeling tabular data. And so that's what we're going to do today. We're going to go to the Kaggle.com platform again. So we're going to go to www.kaggle.com/learn, and then we're going to scroll down, and we're going to come to, you see I have all of these. You're welcome to try any of these that you like, but we're going to come to intermediate machine learning. So we're going to hop in there, and these earlier examples do a lot of nice things with data cleaning, which is probably 90% of what you do in data science. But because we want to get a lot of machine learning practice under our belts early on, we're going to go ahead and try to play around with this exercise 12, which is the XGBoost.
Yeah, and another reason to go to XGBoost is that XGBoost is one of the more advanced machine learning model out there, and I believe the XGBoost models have won almost 50% of the Kaggle competitions.
Yeah, it's really remarkable how many times and in how many different situations the XGBoost algorithm has been used. And part of that's because it's an ensemble method. You can use XGBoost to take in predictions from multiple other models and then use it to make a prediction from that. So it's really plug and play. You can put it in a lot of different places.
Yeah, and it's a cyclical ensemble model. Basically, what that means is that in every run, it adds a new model to your machine learning prediction, and with each new model that is added, it tries to improve the prediction that it is trying to make. So generally what we have seen till now is that XGBoost gives you a pretty decent prediction accuracy, and yeah, that's the reason we wanted to come to XGBoost, so that we can at least show you that what is the most advanced machine learning model for tabular data out there.
Yeah. So this is what the graph of what Ravi was just talking about. It's a cyclical ensemble model, and so as with what Ravi was saying, first it starts out training a model that's just really basic. It makes some predictions, calculates the loss, and then instead of scrapping that model or training or modifying the model, it actually just trains an entirely new model based on that loss function, and then it adds the new model to the ensemble, and then makes predictions based on those two models, and then so on and so forth until you tell it to stop. All right, so we're going to go ahead and just get right into it.
Yeah, and like every time, once the lessons or the link before this exercise is going to give you more information about XGBoost. So at the top you'll see there are two tabs open. One is for exercise of XGBoost, and the second one is just XGBoost. So if you want to get more information about what XGBoost is and some other nitty-gritty details, then yeah, please feel free to go over there and read through them. That's a very small text that they have, so it should not take you a long time.
Yeah, and if you want really nitty-gritty details, we're going to post the link to the XGBoost documentation for the implementation that everybody uses in the information section of the video, so that you can go in there and really dig down deep into it if you like. So let's get going. So this is a Jupyter notebook. Again, it's a web-based platform which allows us to have nice, pretty comments along with our Python code, and then just look at the output of the Python code directly in the web browser. This particular Jupyter notebook is hosted by Kaggle, but if you saw the video last week, the number 4 video, we did autoencoders with denoising the MNIST database. That Jupyter notebook we did there, we were able to run directly on the UAB high performance computer Chiha. But this particular one is hosted on the Kaggle website. So let's get going. So first things first, we gotta set it up. And this particular setup, this isn't something that you would do in every Jupyter notebook that you run ever. But these are the libraries that Kaggle uses to give you the checking function to see whether or not you put in your code correctly. All right, and then let's see what this is. So for this exercise, we're going to work with the housing prices data. So we're going to try to predict house prices based on some other information in that spreadsheet.
And it's the same competition, or it's the same data set that I think it's the same data set that we were using while building our first machine learning model as well.
Yeah.
If you take a look at our earlier videos.
Yeah, I think videos 2 and 3 use the same data set. So first things first, so these first 2 lines are importing libraries that have functions that we want to use. Pandas is a data manipulation toolbox, and then and it's got a lot more to it, but that's kind of the simplistic explanation. And then sklearn is a really nice machine learning model library, but it also has some really nice helper functions. And this particular one, train test split, splits your data into, you give it one pile of data or one CSV, and then it will split it into training and testing so that you can train your model on one set of data and then test it on another set of data that it hasn't seen before. So let's see, we'll go down and we'll see a little bit more about that in a second.
You would have noticed that we, in almost all of our classes, we have mentioned why it's important to split your training and testing data. That's just because it's really important. So yeah. We try to emphasize that every time we come across this train test split.
Yeah, it's just anytime you come across it, it's really useful to remember and remind yourself and make sure that you're doing it. Because if you don't have a separate training and testing database, then you're going to get a lot of questions later when you try to publish or publish your model or publish a paper based on your model. So first things first, we're going to read in the CSV file. And if you had your own CSV file, you could plug it in here instead. If you downloaded this Jupyter notebook, you could download it and then put in your own CSV file, and this would work just the same.
Yeah, and there is that add dataset button at the top next to the exercise. So if you wanted to add your own dataset, we might have another video where we might show how to add your datasets and stuff.
Yeah. So we're going to read in the training, we're going to read in the testing data set separately, and then we're going to remove rows that are missing some values that we want to use for our predictions. And this is part of the data cleaning that's going to be in some of those other Jupyter notebooks that we skipped to get to where this one today. But you can go back and take a look at those. But basically, if you're missing some data, that can throw off your model because it's expecting to see something. And so if you don't deal with that somehow, it can give you some false results. Here, so you notice we have a testing database, and then we're going to use that train test split to give ourselves 20% of our data into a validation data set. So this is just, we're being very rigorous with how we're splitting up our data. So we have training data, and then during training, we're going to do validation, which will demonstrate on 20% of our data set that we get the same prediction that we get on the rest of the 80%. And then we have the testing, which is what we're going to look at afterwards to make sure that we really have a generalizable model. Let's see. Cardinality. So this is kind of a data cleaning and prep thing. This looks like we're looking at columns that have a low number of unique values. I'm not sure whether or not we'll use that later. Oh yeah, it looks like we do. And then numeric columns. So we're going to use the numeric columns. We want to use a lot of, because those are really easy to train and prep. That's my guess. All right, and then in the end, we're going to put everything into these X_train valid test, and that will give us just some nice handles that we can use to call the data later. So let's see. So now that we've talked about that, let's run that cell. All right, so we can go down and invalid syntax. Let's see, what did I miss? Oh, so if you notice, I have this selected, and this little play button has the cursor on there. So if I hover, it's executing the highlighted code only. So very nice feature to have, but not what I was intending to do. So let's try that again. All right, so now that we ran the whole cell, we don't see anything coming out of it. So yeah, that's what we were hoping, that there wouldn't be any output there. All right, so now we're gonna build the model. And this is what we did a few times ago where we did the random forest, but today we're going to use this XGB regressor, which is a XGBoost based regression algorithm, because we're not looking for a classification, which would be this or that. Houses in one area versus houses in another, or dog versus cat. We're looking at housing prices, which is going to be a range of values. So let's see, we're going to put in XGB regressor, and let's see, as with the previous ones, it's asking us to set our random state equal to 0. So again, when you're doing this just for your application, the random state doesn't matter. You can put whatever random state you want, but for the purposes of making sure we all have the same output, so this checker function works, we got to have that stay the same. All right, and then we're going to fit the model based on our training data, X_train and Y_train. All right, so then that's my model 1.fit. And I think we do X train first, and then Y train next. So what this is saying is, okay, my model is the XGBoost regressor, and then I want to take that model and I want to fit it or train it based on my X data is going to be this X train, so those columns that I selected up here, and then the Y data is going to be the Y_train, which that should just be the house prices for those particular rows. And let's hit that. All right, so it says that we were correct, so we filled that out correctly. You'll notice in this particular notebook, at least in mine, it looks like they forgot to remove these hints from inside. So if you get confused, you can always just look down and see it here. But we can run that. But you see that theirs is the same. That here, they're just giving an example of where it should fail because we didn't actually fit the model. And then here it passes because we set up the model and we fit it. All right, so that's really all we need to do to start making predictions with this model. We can go ahead and pop in here, my model _1 dot predict, yeah. And then we want to make predictions for the validation data, which is stored in x_valid. x_valid. Okay.
That should be it.
Yeah, that should be it for that cell. And you see with our handy dandy hint that's not covered up, that's the same thing they did. And now we want to check how right our answer was. And so we're going to do that by taking the mean absolute error. So that would be taking basically subtracting our predicted house prices from the actual house prices and then averaging them across the whole data set. But sklearn has a really handy dandy function for that called mean absolute error. And so we're just going to use that instead of calculating that ourselves. So we're going to do predictions and y_valid.
Yeah.
And then let's uncomment this so we can print it out. All right, so it looks like using this XGBoost method, our mean absolute error is about 16.8 thousand in the house price, which is almost half of what it was using random forests, right?
Yeah, using decision tree.
Oh, decision trees. Okay.
Yeah, so using decision trees, it was about 28,000, the mean absolute error.
Yeah.
And just using XGBoost is having your mean absolute error to 16,000.
Okay. All right. So again, we look down and see that's that's the way that's supposed to work, and we got the same answer they did, which is great. But now we want to improve the model. So just like we did in a previous session with the decision trees or the random forest, we can change the parameters, often called hyperparameters of the model, and have it hopefully improve the training. So we're going to set up another instance. So we're not going to change my model 1 at all. We're going to make a my model 2. And we're going to set it up with some certain hyperparameters. All right. And see how that does. So they're saying, use what we learned in the previous tutorial to figure out how to change the default n underscore estimators and learning rate. So we're just going to put n underscore estimators, and then we'll also just go ahead and put in learning rate. Let's see. Because we skipped around and I'm not sure which tutorial they're talking about, I'm just going to put some numbers in there. Do you have some thoughts as to what numbers?
Yeah, you can put in estimators as 1,000.
Okay.
And learning rate as 0.05. And I'm not just guessing. So it's basically in that previous XGBoost they mentioned
over here.
Yeah.
So if we go down here, parameter tuning, here we go. So in estimators, too low gives us underfitting and too high gives us overfitting. And
the typical value is from 100 to 1,000.
Okay, typical value is from 100 to 1,000.
And then there's
And-
learning rate parameter.
Yeah, and then there's the learning rate. All right. Learning rate. All right, so that's what they put in here is,
Yeah.
okay, so as a default, this is what I was interested in. As a default, the learning rate is 0.1.
Yeah, and basically what it means is, what learning rate means is that, like we told you earlier, that XGBoost is a cyclical ensemble model. So learning rate is basically what it should learn from the previous model that it ran, and it can bring forward that whatever it learned over there into the next model. So you are gradually improving your model, your current model, by whatever is the learning rate that you provided.
Yeah. All right.
And I think that's the reason for the name gradient boosting.
Yeah. All right. So then we're gonna fit this model. And again, 1,000 is kind of the upper limit of normal on the number of estimators, and the learning rate is default is 0.1. So we're just having the learning rate, which is again nice for not overfitting our data, because it learns slower than it would if we had a higher learning rate. And then we're going to go dot fit. And in here we're going to put x underscore train, y underscore train. And I saw another thing in there, they said early stopping. And we have validation set. So let's put all that in there. All right. So what does early stopping do? So I believe early stopping basically just allows the model, if it's kind of settled down into a prediction range and a certain amount of errors, then it can stop early.
Yeah. Whenever it sees that your learning rate is platoon, like it's not improving anything, then it's going to stop.
Yeah. And then this evaluation set will allow us to see how the model's doing on a learn by learn basis based on our validation data set.
Yeah. So basically, sorry, I was still talking about that early stopping round.
Oh,
thing.
yeah.
Yeah. So basically, what this value 5 denotes is that if over the last 5 rounds your learning rate is not improving, so either it's plateauing or it's taking a downturn in the last 5 rounds, then it will stop.
Oh, okay. So basically, if the error or the loss is the same for 5 rounds, it will stop.
Yeah, loss or
if it starts to go down for 5 rounds,
then
it will stop.
Yeah.
And give you the better model.
Yeah.
That makes sense. All right. So then, this evaluation set is what I was saying. Of this should allow us to see how the model is generalizing as it's being trained, and then we'll go ahead and pop this in here. My model underscore 2 dot predict, and we're going to do underscore valid, and then this is mean absolute error predictions underscore 2 and y underscore valid, and then we'll print that out. Now, since I changed this verbose flag to true, this may give us a lot of printout. Verbose just means that we want this function to tell us a lot about what it's doing. So let's see. Oh, yeah. Okay. So let's see. It is going to continue training until the validation root mean squared error hasn't improved in 5 rounds. And it's going, and it's going, and it's going. Is it still going?
All right.
Oh, there we go. So it kept on going for 172 rounds, but it plateaued starting out at about 167.
Yeah, if you're going to take a look at the values, you'll see that number is decreasing till 167, and after that it just starts.
It starts to increase again.
Yeah.
Yeah, that makes sense. All right, and so then our mean absolute error using this model is 16,751, which is a little bit less, about $100 less than the other one. So we did improve it,
but not by a huge margin. It was just small gradient.
Yeah,
boost.
just a small, but that's all right. It still got better. And you can see those are the parameters that they used. Now this next part is kind of fun. I think we're supposed to try to make it worse.
Okay.
So we can use the same thing. So XGB regressor, number of estimators.
So we had 1,000.
We had 1,000, so we could go to the opposite end and put 100 in there.
Yeah.
And then our learning rate
was 0.1.
Was 0.5.
0.05, yeah.
Yeah. So what do you want to do for learning rate?
I don't know. So 0.1 is the default. So
yeah.
Let's go to 0.3.
Yeah. So we'll go higher. We'll go lower estimators and we'll go higher learning rate. So theoretically, we should underfit.
Yeah. We are celebrating the diametrically opposite day. So.
Yes. Yeah, I never went to, I was homeschooled. I didn't go to a regular school, but I know that sometimes they have those opposite days where you're supposed to wear your clothes all backward and all that kind of stuff.
Yeah.
So that's what we're doing. All right, so we're going to train on that, and then y_train. And then predict. And we're going to predict based on x_valid. And we're going to look at our mean absolute error between predictions _3 and y_valid. And we're going to put that out. All right. So we broke it pretty nicely. So we only improved it here by about $100, but we made it worse by about 1,000.
Yeah. Yeah. So it's just like the saying that destroying things is easier than building them up.
Yeah. Oh, here it looks like they tried it with just one estimator. Oh, and they broke it even more spectacularly. So the mean absolute error, when you're only using one estimator, makes sense. So it's 163,000.
Oh wow.
Yeah.
Okay, I thought we did a bad job.
Yeah, I thought we were doing a good job of being bad, but apparently not enough. All right. So as always, there's more things on this website that you can go and play around with once you're here. Feel free to do that. Feel free to come in and talk to us about this or any other data science questions you have during our office hours during the week, or just shoot us an email or leave a comment on the YouTube video.
And yeah, keep in mind that all the exercises that we do in Kaggle, they have a corresponding notebook that gives you more information about the things you're doing in the exercise. So please try to go through them as well. We generally try to show you most of the important things from that corresponding notebook. But yeah, it would be a good idea to go through them once and then go through the exercise notebook.
Yeah. And if we don't have enough resources for you to learn everything that you want to learn, post it in the notes, then just let us know and we'll get you more resources. But yeah. All right. Well, we will talk to you guys next week.
Yeah, have a nice long weekend.